Test. 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 Okay, sorry for the technical difficulty. I was adjusting some settings. Okay, welcome to tonight's Facebook Live, brought to you by Maths Heuristics. So if you haven't already, you can go to mathsheuristics.com/blog. Okay, let me check out some things first. Okay, looks fine. Can go to mathsheuristics.com/blog to download the notes. Okay. So a bit about myself. I'm the curriculum specialist here at Maths Heuristics. My name is Kevin Huang. I've been working here since 2011. It's going to be my 9th year of service soon. And the thing about me is that I like teaching maths a lot. It's something I can't really explain why I like it, but I just do. Okay, so much so that I went to study maths in university. And after that, I've joined Maths Heuristics full-time. Anyway, okay, let me make this introduction really brief. So today's session will be based off the Mastering Heuristics series. And there are 5 books which has been authored by my boss, Mr. Sunny Tan. And today's session will focus on spatial visualization. Okay? So what is spatial visualization? It is the ability of one's mind to manipulate shapes within his mind. Okay? And today I'll be talking about that. So these books can be viewed and browsed through at mathsheuristics.com/learning tools. Let me just type that out real quick. Okay. And it's strange. Okay. So to give you a brief idea of what it's like, you can see the ebook version here. Okay. The ebook version describes the various ways that these challenging problems in area and perimeter can be solved. Okay? So the way it works is that there will be several examples and a one-shot working solution. If you do not understand these workings, you can go on to read up on the thought processes on how the workings are derived. And I think the thought process nowadays is important because as you all have seen the recent PSLE questions, they are getting more and more unfamiliar, and it's presented in a very refreshing angle, I would put it that way. Okay, the complaints that I've heard about is that the paper is too tough and all that. I can understand where you're coming from. It's a natural reaction to be protective of your children. At the same time, if one were to analyze the paper logically, analyze the questions that we know so far logically, the questions have all the points that has been taught in school. It's just that it's presented in an unfamiliar context. Okay, this was what I mentioned in the interview with Mothership, so let me just give a shout out to them. I want to thank Mandy Howe for introducing us to Lauren and Eileen of Mothership for giving us the interview. Okay, thanks to y'all for that. Okay, so today let's begin on the on spatial visualization. Oh, by the way, that day the interview, right? It was a lot more intense than this. I thought that I'm used to speaking on camera already, but I was totally wrong. It was very, very frightening. Okay, so anyway, let's come to this first question. So on spatial visualization on visual clues. The figure below shows 5 identical squares. Now I don't know whether you can see it or not, but this is the PSLE circle question that has been modified. Okay? Shows 5 identical squares. You want to find the length of each square, and you want to find the perimeter of the figure. So like what I mentioned before, spatial visualization is the ability of one's mind to manipulate and see certain shapes within his mind. Okay? Now how do we do this? Find the length of each square. I'll present this in a few ways because I think that there's a lot of criticism that says that this heavily favors the GEP and the Maths Olympiad trained students. Personally, I would beg to differ lah. Okay? So let me show you how this can be done. In a very simple way, find the length of each square. I've prepared this PowerPoint presentation for you. Okay? So let us look at just these few squares alone. Okay? Now, what's going to happen over here? If I were to slide this out a little, okay, can I bring your attention to this point and this point? This distance that's jutting out will be produced on this distance that's jutting out. Okay, hello to Christine Jia Jun. Okay. Okay, so if I were to slide it out further, this distance would now be the same as this distance over here. Can you all see that? And again, if I were to slide it out further, this distance will now be the same as this distance here. So what is the point that I'm trying to make? If you're able to see this movement, if you are a visual student and you are able to see this point, then you would be able to extend out the reasoning that if this is 22 cm, then this has to be 22 cm as well. Agree? And by that similar reasoning, if this were to be 22 cm and you slide it out over here, this would also be 22 cm. So if that is the case, then this would be 10 cm and this would be 10 cm. Agree? So based on this reasoning, okay, let me move my mouse a little. We can say that if this is if this is 10 cm and this is 10 cm, then the length of each square would simply be this entire portion over here. Okay, let me try to find a better color. Okay, this portion here would then simply be 10 cm plus 16 cm plus 10 cm to give you 36 cm. Okay, so this would settle part A. The length of each square. Okay? So for part B, we are to find the perimeter of the square. But before I go into that, let me describe another way of solving this. Okay? Just so that you know that it's not a one-sided kind of question. So the other way of solving this is to say that let L be the length of the square. Okay, and when we have this entire distance here will be L. If this is the length, then this is 12. Then this is also the length. This is 12. You have one more length over here. Correct? So over here, L plus 12 plus L plus 12 plus L gives you the entire distance from here to here. Now at the same time, if we are to look at it from the bottom perspective, here there's a 22 cm, here there is another length, here there is a 16 cm, here there is another length, and here there's a 22 cm. We can say that these two are the same. These two will produce the same distance. Okay, and if we are to simplify it, okay, I think my head is going to get in the way. If we are to simplify it, then we would say that 3 lengths and 24 would be the same as 2 lengths and 60. Okay? Let me try to make all this smaller first. Oops. So once we have this already, through algebraic manipulation, you can see that the length is actually 60 minus 24 to give you 36 cm. Okay, so if you can't really manipulate this, if you're not too sure about the algebraic manipulation, you can also resort to models. Okay, there's 3 lengths and a 24. And there's 2 lengths and a 60 that produces the same length. And then if we are to compare between length with length, numbers with numbers, you would see that you would obtain the same conclusion that your length is 36. So you can see that in this aspect, there are several ways around this problem. There are several ways that this problem can be done. And I think that's the beauty of the PSLE questions. It is set in a way that it doesn't discriminate one group of students' ability over the other, because there are many ways that the problem can be solved. Okay? So let's move on to part B. To find the perimeter of the figure is simply the outer boundary of all the lengths. It is the length of all the outer boundaries. So over here there's 1. How many lengths of this square are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we've accounted for all the square lengths already. There are 15 of them, and there's a 22, a 12, a 16, another 12, and another 22 that we have to account for. So when we have all this, we know that there are 15 lengths. And there are these 22 cm, 12 cm, 16 cm, 12 cm, and 22 cm that we have to add up. So doing all this would give us 624 cm, and this will settle part B. Okay? Okay, listen first, listen first. Okay, if you don't get it the first time round, go and view the replay. It will be up later on. Okay, don't worry, I won't delete this. Unless there is a bug with Facebook, which happened before. The bug from Facebook caused all my 2018 videos to be deleted. That was during the Facebook outage, somewhere in April. But good thing lah, this year I backed up all my videos in YouTube. Yeah, okay, Mikey, I'm feeling a bit better now. Hi, Ai Hui. Okay, so let's move on to the second question. Now, two triangles are embedded in a rectangle, WXYZ, measuring 9 cm by 8 cm. So given that the area of the shaded figure is 27 cm squared, find the area of triangle VYZ. So we are to find this triangle over here, VYZ. Okay, so how do we go about doing this? Now, to deal with this, we have to observe very carefully where the base is. The base is over here. And what does that imply? If this is the base for these two triangles, no matter how they look, as long as their perpendicular height is the same, their areas are going to be the same. Okay? So let's, because this is V, right? Let's just call this point Q. Okay, you will see that this white area and this shaded area, the area of VZY and QVZ. Okay. QVZ. What is this area? What is the area of this entire triangle? You want to try to group them up together first to make sense of certain things. Of course, if you're able to see it very quickly, you'll be able to tell me that these two shaded areas are the same. Okay, but why is it the case? Why is that the case? Because if you look at this triangle here, ZYQ, the area of ZYQ would simply be half times base 9 cm times perpendicular height 8 cm. That will give you 36 cm squared. Okay, and at the same time, okay, please do not spam the chat. Concentrate on the lesson. At the same time, if you view Z, Y, and X, this triangle here, you would see that VZY is common between them, and XVY would also have to produce the same area because its area is also half times 9 cm times 8 cm. And this is why these two areas, the two shaded areas, are the same. Okay, important thing to note here is that the two triangle QZV and triangle XVY's areas are the same. You all have that? Yeah, the answer is that. Yeah, okay. So based on this, right, we can then take 27 cm squared and divide that by 2. Once you have established this, once you're able to see this, this becomes 13.5 cm squared. So we want to remove that away from one of these. We just take 36 cm squared minus 13.5 cm squared. And this would give us 22.5 cm squared. And this would be your answer. Okay? Yeah. Okay, I don't think I've fully recovered yet. There's still a lot of phlegm inside my body. When the weather is heaty and all that, when the weather keeps on changing from hot to cold, my body responds in this manner. Yeah, so don't worry about it. I can't really talk with as much energy as I could last time. But don't worry, this too shall pass. Okay, so anyway, let's go on to number 3. The figure below is not drawn to scale. It is made up of 4 squares and a rectangle. So the shaded rectangle has a perimeter of 32 cm. And the total area of the 4 squares is 120 cm squared. We are to find the area of the rectangle. Okay? So over here, 2 things you have to know is that if you've been following me religiously, you would know that when you see a problem like this involving squares and a rectangle, the first thing you ought to do is to mark out all the lengths that are equal first. Okay? By doing this, it will help you to spot certain clues as to what your next action should be. Okay? Elise, you try to log out and log back in again. Okay? So over here, they didn't say that the perimeter of, the length or breadth of the rectangle is that of a whole numbered measurement in centimeters. They didn't say anything about that, so do not assume that that could be done. Okay, so what else can we say about all this? Now, 2 of these red lengths and 2 of these blue lengths would add up to 32 cm. That's what we know with certainty. What we can do now is to say that 1 long plus 1 short will give us one long length and one short length, would give us 32 cm divided by 2 to give you 16 cm. Okay, which rectangle am I referring to in the figure? The shaded one. Okay, so this is one length and one breadth. If you need to write down what this is to help you to be aware of what's going on, do it. Okay, try not to cut corners. So that's what we know for sure. What can we do next? Now you see that if you view one length and one breadth from this angle, that's not going to help a lot. You can't really do much with it. You can try to do a guess and check to find out the area of the rectangle, but I don't recommend it for this question because there is no restriction. So what you can do instead is, if you view this length, and this breadth instead, this, if you are to extend this portion up, if you have to draw out these lines over here, you can see that there's this length of the square as well, and this would produce another length on this side. So when we know all this already, the next thing we can do is we can say that this would have a length of 16 cm. And this would have a length of 16 cm as well. Correct? So when we have all this ready, we can find out the area of a square. Let's do that first. An area of a very big square. This would give us 256 cm squared. Okay, so this 256 cm squared is the area of this entire square over here that we have artificially created. Okay, what else can we find? After we know this, we see that this rectangle is exactly identical to that. This rectangle here is the same as this rectangle here. So let's just shade that up as well. So now, in order to find out the area of two rectangles, we have to get rid of these two squares first. Then how can we do that? We look back at the question for further information. There's the total area of the four squares is 120 cm squared. So if we are to take 120 cm squared and divide this by 2, this would give us 60 cm squared, which is the total area of one big square and one small square. Okay? So when we know this already, the next thing we can do is to find out the area of the rectangle from here. The area of the two rectangles would be 256 cm squared minus of those two squares area. And this will give us 196 cm squared. So one rectangle itself is going to have an area of 196 cm squared divided by 2 to give us 98 cm squared. Then this will be your answer. Okay? Yep, Melvin, you got it. Okay, if you got it, please spam the like button. Yep. So that is why we mentioned that you should always mark out all your equal lengths first. This will give you a clue. It will make your probability of finding out what to do a lot higher. Okay, it will raise your chances of finding out the next step to do. I wouldn't guarantee it. Some students would still not be able to see it. Okay, but it will raise your chances of getting it correct. Okay, thank you for spamming the like button. Okay, now let's move on to the last question here. Now this is a question from paper 2, and this is a 2-mark question because this one is a question 3. So it's a 2-mark question. It should be simple, correct? The keyword here is it should be. But this is a question that a lot of people cannot do or cannot get it correct on the first try. Okay? So over here, in the figure below, rectangle ABCD has an area of 120 cm squared. Find the area of the shaded part. So let's see what we know. We want to find out the area of the shaded part, and we are not given the lengths directly. So what can we do? We want to try to find out the entire area of the rectangle first, find out the area of the breadth, then remove off all these 4 unshaded portions. Now that looks okay, but in this question it can't be done because you're not given the total length and you're not given the total breadth. So you'll be like, oh no, what should I do? Okay, so here's what you can do. Stay calm first and try to analyze it by isolating all the regions. And let's look at what we end up with. Okay. So over here, what can we say? It's not the P6 foundation. Okay, right now, what can we say about this figure? All we know is that the area of the entire rectangle is 120 cm squared. But you do not know this individual portion, you do not know this individual portion, you do not know this, and you do not know this. So having drawn out all these lines already, what other information can we infer from this diagram? Okay, Jensen, this red swastika is a school in Singapore, primary school in Singapore. Okay, what can we do from here after we have isolated everything? You want to try to draw the lines, you want to try to rearrange them, but you can't. You see that you can't really proceed further after having drawn out these lines. So there's one more step you need to do before you can go on with the question. What would that be? So after staring at this for a while, there are 2 things you need to know first. Okay, first of all, when you have a rectangle and you cut it through its diagonal. When you cut a rectangle or a square through its diagonal, it will split it into 2 equal portions. This is the first prerequisite you have to know before you can solve this problem. Do you all agree with this? Okay, just think of it for a while. You have a rectangle, you cut it through its diagonal. You will split it into two equal portions. So once we have that, you can see that this and this, these two triangles would have an equal area. Then this and this, these two triangles will have the same area. Doesn't really matter what they are. Okay? Then I don't know what other kind of symbol is there. Okay, this and this forms up the same area as well. And okay, I'm not too sure what to do. What symbol to use already. So this and this will form up the same area as well. Correct? Then you observe one thing. There's this little rectangle here that has not been accounted for. So you can see that this, although this is a 2-mark question, it's also not that simple. Okay? Looks like yin and yang. So how or what is the area of this rectangle? This part we can find, because if this side here is 4 cm and this side here is 2 cm, then this would be 2 cm. Okay, and similarly, if this length here is 12 cm and this length here is 4 cm, this would be 8 cm. And this is why I believe the model approach is important, because you are in model approach theory, you are trained to look at the distances to find out the value. Okay, so do not try to skip that. Not every kid is naturally gifted. Okay, so if this is 8 cm and this is 2 cm, then the area over here will be 16 cm squared. Correct? So what else can we say? We can say that if we are to compare the shaded portion with the unshaded portion, the first thing we can say is that you have the area of 4 triangles here and a 16 cm squared. Okay, and for the unshaded portion, there are the areas of the 4 triangles as well. So 4 triangles, 16 cm squared. All this would add up to the total area of the rectangle, 120 cm squared. Correct? So if we represent it this way, it becomes a lot clearer to explain, a lot clearer for you to understand as well. And once we have that, to find the area of the shaded part, all we have to do is to add another 16 cm squared here. And this would give us 2 bars of the same length now. Okay, this would give us 2 bars of the same length. Can you all see that? When we have that, we can just divide this whole thing by 2. And this would give us 68 cm squared. So this would be your answer. Okay? Shh. Don't spam the chat, please. Okay, so that's the end of tonight's session. Okay? So if you like what you see over here, I got good news for you, because we will be conducting the workshop for spatial visualization on area and perimeter. Okay? This PSLE marking workshop days. Okay, it's for P4 and P5. For P4, we will focus more on fundamentals and some unconventional problems. For P5, we will cover the more commonly used spatial visualization techniques. So these are the course fees for spatial visualization and unit transfer method. A complimentary guidebook with access to our video. Okay, now no more mobile apps. Web video and virtual classroom consultation will be given, along with all these workshop materials that we'll be covering. Okay, so there's the spatial visualization. For those of you who haven't attended, the unit transfer method is here to solve most of the word problems. Okay, I emphasize on word problems because I do not believe that this can solve every single question. Okay? I do not believe there to be a universal method. Let me put it that way. Okay? So this unit transfer method is meant to solve the challenging word problems. And let me just be upfront with you. Okay? It cannot solve certain problems like patterns. It cannot solve certain problems that involves systematic listing. Okay, it's not able to do that. But for all this, we have the heuristics approach to problem solving. Okay, to cover up the gaps. So this would be for P4. It will be on Tuesday to Wednesday, 10 a.m. to 1 p.m. The course fees are all here. You can refer to mathsheuristics.com/schedule for more information. Okay. Right, so anything that you want to ask about? Because this is the end of my presentation already. Are you the one teaching? Oh yeah, I'm the one teaching. I'm the instructor teaching all these courses. For P4 and P5, I'll be taking them. I'll be taking all the courses. How about last week's class you told me? Wykit, which one are we talking about? Okay, you're welcome, me. Okay, any questions? It's a lot quieter now that the P6s have finished their PSLE. The question. No, I thought your mom said that you went through the replay. Then I thought you understand it already. How to use virtual classroom. You can schedule an appointment with us for consultation. Arisha. Yeah, I remember name very well. I can't remember the face that well, but I can remember the name quite well. Arisha, correct, right? Your name pronounced correctly, right? Okay, so this is a last burst kind of revision for all of you, if you want to attend. Okay, these are the two courses that will have the complimentary guidebook. Okay, you're welcome, Eunice. Okay, so I'll give you about another 2 more minutes. If there's nothing, no question, then I'll log off already. I also need to go back earlier to sleep. No, these days the weather has been really crazy. One moment it's very hot, one moment it's raining. Then There are times that it's shining, the sun is shining down, and it's also raining. Okay, you're welcome, Rashina. Eunice, are you close to your router? Okay, good night, man. Sun and rain, sun and rain. Okay lah, so I guess I'll log off now. See you all soon. Okay, this is Kevin from Maths Heuristics signing off. Good night. Bye bye.